Hi guys, welcome back. So we're going to do day 4 of Unit 3, proving lines that are parallel. So we're going to be doing the opposite of what we have been doing. So if we have a certain amount of angles, then you can prove that two lines are parallel, okay? So because of parallel lines, we created angles. Now we're going to go the opposite way. So proving parallel lines using converses. So corresponding angles, converse postulate. So if angle N and angle Y are congruent, then A and B are parallel. And parallel line, you can use that code to have line A and line B A and B are lines that are now parallel because we proved that N and Y are congruent. And those are corresponding angles. Now let's try it with alternate exterior. Same idea. So if angle L and angle Z are congruent, then A and B are parallel. Lines A and B are parallel, okay, because those are alternate exterior. Now let's do consecutive interior. So consecutive interior actually should not be congruent. What are they? They should add up to 180. So if angle M and angle W are supplementary, they add up to 180, then line A is parallel to line B. And then the very last one, alternate interior. So alternate interior means that they're on opposite sides of the transversal and they're on the inside of the parallel lines. Okay, so all of these are congruent except for consecutive interior. Consecutive interior add up to 180. The rest of them should be congruent. All right, so let's get to it. So in each example, determine if the lines are parallel or not, explain why or why not. So let's look at these two angles. So 127. So what type of angles are those? Well, those are corresponding angles. So corresponding angles are congruent. Then that means that the lines are parallel. And you can write, so those 3 dots mean therefore. Therefore, the lines are parallel. Okay? All right, let's try the next set. So number 2, inside or outside? All right, 127. So these are on the outside, and they're on opposite sides of the transversal. So the transversal's there, so alternate exterior. So alternate exterior, those angles are congruent, so therefore we have parallel lines. Good. Okay, let's look at this next one. Okay, so 120 and 60. So they're on the same side of this transversal. Okay, so that's consecutive. That's consecutive interior. And because they add up to 180, you have parallel lines. If they were congruent and they didn't add up to 180, it would not work. All right, the very last one, vertical angles. So let's look at our list. So I have corresponding, alternate exterior, consecutive interior, and alternate interior. So A, these are vertical angles. So vertical angles have nothing to do with this parallel line. Okay? So we can't prove that they are parallel. Okay, so we can't prove that they are parallel because it has nothing to do with the second line. All right, so let's try these ones out. Okay, so number 4, what are these? Number 5, what type of angles are those? And B, what type of angles are those? So try those ones out and check back with me on your answers. All right, so here are your answers. Alternate interior angles are for number 4. Number 5, those are consecutive interior. And because they're congruent, they are not parallel lines. You cannot prove that they're parallel lines because they should not be congruent. They should add up. You should add up to 180 degrees, okay? If it said something about 90 degrees for both of them, that would add up to 180. But because they're congruent, instead of adding up to 180, they're not parallel lines. Okay, and then for B, that is a linear pair. You can't prove parallel lines because, again, it has nothing to do with this parallel line. It only has to do with the top line in that relationship. All right, so we have to prove if they are parallel or not. Same idea, given that A and B are congruent. So they told us that they were congruent, okay? So again, these are congruent, and they are alternate. Okay, here's the transversal. So they're alternate interior. Okay, so alternate interior. So yes, J is parallel to K. A and B are congruent, okay? Well, they're not corresponding. They're not in the same spot. One's on the inside, one's on the outside, so can't prove it. Okay? You can't prove that they are parallel. All right, C. Well, here's a tricky one. So this is 90 degrees, therefore those are 90 degrees based on the perpendicular information, okay? So perpendicular, and they're on the same side, so they're consecutive interior. So they must add up to 180, and because they're both 90 degrees, they both do add up to 180, so yes, J is parallel to K. All right, so let's get into actual numbers. So find the value of x that will make the two lines parallel. Okay, so I need to figure out the value of x for A. Okay, so if this is corresponding to 124, so this would have to be 124 for A, excuse me. And then these are also corresponding. So if this is 132, this has to also equal 132. So 58 plus x, which equals 132. So because they're corresponding, they have to be congruent. So x would equal 74 because these two angles add up to 132. Okay? All right, now let's try the next one. So these have to be congruent in order to make parallel lines. Or alternate exterior. So I have 4x equals 3x plus 30. So I'm going to subtract 3x to both sides. I get x equals 30. Okay, I'm going to plug it back in and see what I get. So I get 120 degrees for each of them, and they're congruent. All right, now let's try D. So these are alternate interior. Now let's get our x's together. So I subtracted 2x, added 10 to the right, and now I'm dividing. So I got to move things over. So I move this over, and I move the 10 over by changing the sign, and now dividing. So then I can plug 20 back in. So they both equal 90 degrees. All right, now let's go to transitive parallel lines theorem and then perpendicular parallel theorem. All right, so transitive parallel lines theorem. So if you've heard of if A equals B and B equals C, then A has to equal C. Okay? It's putting like those two letters together based on the other information. So parallel lines theorem. So if P and M are parallel, and M and N are parallel, therefore P and N are parallel. Okay? So based on the relationship of P is with M and M is with N, therefore P is now parallel to N. So transitive meaning, so if one goes with one, if A goes with B, B goes with C, therefore A goes with C. The same idea can happen with parallel lines. Therefore, all three of these are parallel to each other. Okay? Okay, so the streets in Reno, so if I have First Street, I have Third Street, and I have Fifth Street. Okay? If these are parallel, and these are parallel, therefore, First and Fifth have to be parallel also. Again, based on the relationship that they have with Third Street. Okay? The same thing happens with perpendicular parallel theorem. If M, so this symbol means perpendicular. Okay, that's the 90-degree corner. So they kind of label it like that. So because M and N are parallel lines, so if you ever see this, this means parallel. And because P is perpendicular to M, it has to also be perpendicular to N. So it has to cut through both at the same angle, okay, because of the relationship between the parallel lines and the perpendicular. Okay, so angle 1 and angle 2 are congruent. So what theorem would I use? Well, they are alternate exterior. Alternate exterior angles are congruent. Okay? For angle A, so A and C are congruent, and B and C are congruent. How? Perpendicular, we just learned it, perpendicular parallel theorem. And then the last one, given that we have A goes with C, C goes with B, therefore A is congruent to B. Okay? So we could prove all of these are that line A and line B are congruent based on the theorem or the postulate that's given. Basically, what is the rule and how did we solve it? So why does A go with B? So this is transitive. And that concludes day